Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. Okay, today we are going to cover another two types of system, which are the time invariant or time varying, and the second one is memory or memoryless system. Okay, time invariant system is also known as a fixed system, in which whose parameters do not change with time. Okay, in time invariant, a time shift in the input causes the same shift in the output point. Okay, the same time shift. So let's look at this general equation. For example, if you have the input as x1t, it will produce y1t, but when there's a delay or a shift in time by t0, so the output point will also be shifted by the same t0. Okay, the figure shows the definitions of time invariant, in which the time shift at the input point will result in the same shift in the output position. Okay, a system is said to be shift invariant if a time shift in the input results the same shift in the output signal. Okay, there are generally three steps you need to consider in order to determine whether the system is time invariant or a variant system. So the first step is to delay xt by k. Okay, meaning that inside the bracket, the t or n inside the bracket must be delayed by k. So the equation becomes t minus k. The second step, you need to replace all t by t minus k, all t inside and outside the bracket by t minus k or n minus k if the system is in discrete time system. And the third step, you need to compare the step 1, the output, the equation in steps 1 and the equation in steps 2, okay, to identify whether this system is time invariant or variant. If 1 equal to 2, so the system is time invariant. If 1 is not equivalent to 2, it is time variant. And let's look at the first example. So we need to use the three steps as shown in the earlier slides in order to determine whether this system is time invariant or time variant. So first, delay the input signal. So only delay the input signal by k. So in this case, from here, so yt delayed by k. So no changes on t because t is outside the bracket and it is not belongs to the input signal. So x only inside the bracket of the input signal being delayed by k. So this is the first equation. Next, replace all t inside and outside the bracket by t minus k. So yt minus k equal to t minus k x t minus k. So this is the second equation. The third step, you need to compare 1 and 2. If it is equal, then the system is time invariant. If it is not equivalent, so the system is time variant. So in this case, the we can see that 1 is not equal to 2, so the system is time variant system. And let's look at the second example. This is for the discrete time system. So the first step, delay the input signal inside the bracket by k. So in this case, the input signal is this inside the bracket. So y and delayed by k equal to x n squared minus k. So this is the first equation. Second, replace all n inside and outside the bracket by n minus k. So y n minus k equal to x, n becomes n minus k. So this is the second equation. Third, compare both equation 1 and 2. So in this case, we can notice that 1 is not again equivalent to 2. So the system is time variant. Okay, now the third example in continuous time. So the first step, delay the input signal inside the bracket by k. So you have two brackets here for input signal. So all will be delayed by k. So in this case, y t k equal to x t plus 10 minus k plus x squared t minus k. So this is the first equation. Second, replace all t's inside and outside the bracket by t minus k. So now y t minus k equal to x t minus k plus 10 plus x squared t minus k. So this is the second equation. So the third one, compare the first and the second equation. So in this case, we can notice that 1 is equal to 2. So the system is time invariant. Okay, next system classification is memory and memoryless system. So memoryless, basically the system that cannot remember anything besides itself or its current state. Okay, in other words, memoryless is a system in which the output at certain time t0 depends only on the input at time t0. It does not depend on the future values or the past values. Okay, and memoryless also known as static system. Okay, for example, yt equal to xt. If we try different t values, for example, t equal to -1, so we get y minus 1 equal to x minus 1. If we try t equal to 0, y0 equal to x0. And if we try positive value t equal to 1, so y1 equal to x1. So we can see that all output state only depends on the same t values. Okay, there's no future or past values. So this is the memoryless system. Okay, this is the first example. So let's look at the second example. Second example on memoryless system. So yn equal to x squared t plus xt. So again, sorry, this is yt. Okay, if we try different t values, we'll notice that the same t at the output dependent on the same t at the input point. Therefore, this is the memoryless system, since it does not depend on the future or the past values. Okay, on the other hand, the memory system is the system that depends on other input, for example, the future or the past input. Okay, for example 1, yt equal to xt minus 2. Okay, again, if we try t equal to 0, so you get y0 equal to x minus 2. If we try t equal to 1, y1 equal to x, 1 minus 2 is minus 1. If t equal to negative 1, so y negative 1 equal to x negative 3. So if we look at the states, the current state, so the output of the system at t equal to 0 dependent on the input at the past state at t equal to minus 2. Same goes to these three values. Therefore, the system is a memory system. Okay, so memory system is also known as dynamic system. Okay, the second example on memory system is yn equal to xn plus xn plus 1. Okay, again, you need to compare when n equal to minus 1, n equal to 0, and n equal to 1. So from here, you should notice that the system dependent on the future values. Therefore, this system is a dynamic system or a memory system. Okay, thank you.